Hello, and welcome back to more exponentials or talking about exponents and more properties related to them. So today's video is going to be a little bit different. I'm actually going to introduce a new topic. They're related to exponents. They're actually the opposite of exponents, but we'll get to that. So they're called logarithms. So on your calculator, you might see a button called log, or you might have used it if you're in grade 11, grade 12, you probably know what it is, but if you're not, you've probably seen the log button, and if you've been in a grade 11 course, you've probably used log, but you really didn't know what it is, or how we came about it, what we use it for, what it actually means. So in this video, I'm just going to talk about what logarithms are, how we see them, and what that button actually means on your calculator. So logarithms were actually created somewhere around in the 17th century, if I'm correct, probably somewhere around there. It was used to simplify calculations with exponents. So now you don't see logarithms as often as you used to, but logarithms are still used in sciences, in astronomy, in chemistry. If you're in a chemistry course, you've probably seen it with the pH levels, and it's used there. And in astronomy, when you're using really large distances, logarithms come in handy there as well. So what is a logarithm? How do we even see it, and how do we use it? We know how to see it, but so logarithms, probably on your button, on your calculator, there's a button called log, and that's all it says. So log itself isn't really anything specific, it's just log, but it's when you add in numbers and you add in the actual equation where it makes sense. So before we deal with logs, let's talk about something we already know. If you watch my exponent videos, you probably know about exponents, but let's say we had 2 to the power of 3, right? We know that to be 8. And it's same thing as 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8. So that's what we are used to seeing exponents written as. So logarithms mathematically are actually the inverse operation of an exponent. So if you had an exponential graph and you did the inverse of it, you would get it in logarithm form. But we don't need to worry about graphs right now. I'll make videos on graphs, logarithm graphs, and exponential graphs. Those will come later. But for now, let's talk about what logarithms are. So 2 to the power of 3 is 8. We're used to writing sentences like that. What logarithms give us are an ability to write this exact same thing, but in a different way, using log. So how I would write that using log is I would write log base 2, 8 equals 3. So 2 to the power of 3 equals 8 is the same thing as log base 2, 8 is equal to 3. So essentially what log gives us is an ability to write exponents in another way. That's essentially what a log is. So now I'm going to talk about how logs are written. So you probably already picked up on it for you guys that are really good at pattern recognition. So log base 2, so base is 2, raised to the power of 3 is 8. So in this case, log base 2, 8 equals 3. What is this actually saying? It's saying log base 2, 8 means what power do I need to raise 2 to get 8? And I need to raise 2 to a power of 3 to get to 8. Let's do another example with 3, for example. Let's say I have 3 squared, right? 3 squared is equal to 9. I'm sure we can all agree on that. So how would I write this exact statement as a logarithm? Well, my base is 3, so log 3. So the little number here is going to be my base. Log 3, 9, so that's the number I am getting to, is equal to 2. So the base 3, if I raise it to 2, I get 9. That's essentially what logarithms are. See, 3 squared equals 9. I'm saying the same thing here. I'm saying the base 2 raised to the number 2 is 9. That's essentially what logarithms are. Another way of writing exponents. So log base 3, 9 is equal to 2. So let's do another example. Let's do an example where I give you a log and we find out the exponent version of it. So let's say we had log 4, 16 equals question mark, right? So I was going to give you the answer, but then I thought about why not? Let's deal with it. So what this means here is what power do I need to raise 4 to get 16? That's the answer to this question. So I can write 4 to the power of something equals 16. That's essentially what this says, right? 4 to some power equals this number. So 4 to what power exactly gives us 16? Well, that's 4 squared. If you said that, that's perfectly correct. So 4 squared equals 16. So how would I complete this logarithm? 4 to the power of 2 equals 16. So essentially that's how you deal with logarithms. So let's do one more example. So, or maybe a couple more depending on how much time we have. So let's say we had 3 to the power of 3 equals 27, because 3 times 3 is 9, 9 times 3 is 27. So why don't you pause the video now if you're really interested and write this as a logarithm. I'll wait. I mean, you pause the video, I won't wait. But how would we write that as a logarithm? Again, so my base is 3, right? My base, log 3, 27 equals 3. So the base raised to a power of 3 gives me 27, right? 3 raised to the power of 3 equals 27. So that's how I deal with logarithms. So if I didn't know the answer, let's say I didn't know 3 to the power of 3 equals question mark. I mean, 3 to the power of 3 equals 27. Let's say I didn't know what that is. And this is all I had to me. This is all that was given to me. Log 3, 27 equals something. Well, what power do I need to raise 3 to get 27? Well, I need to raise it to a power of 3. That's how logarithms work. So you have a base, and you raise it to something, and you get your number. Logarithms have their own set of properties. Remember exponential properties, right? So 2 to the power of 3 multiplied by 2 to the power of 3 equals 2 to the power of 6. Well, logarithms also have their own properties, which we'll look at in future videos. But for now, log, again, is another way of writing exponential equations. They're actually the inverse, so they're another way of expressing them. So on your calculator, log is just represented as log, and you don't know what base it is to. So in your calculator, I think default base for log is actually 10. So log base 10. So let's say you have your calculator with you right now, and you want to use this new button that you're excited to use, hopefully. So what you could plug in is you could plug in log. I'm putting the base 10 there, but your calculator probably won't show base 10, or it might. Log 10, 100. So if you plug that in, log 100, you would get 2. And why would you get 2? Well, that's because 10 raised to the power of 2 equals 100, right? 10 times 10, add the zeros, 100. So your calculator has default log base 10. So if you put log base 10, if you just hit log 1000 maybe, you would get 3, because 10 to the power of 3 is 1,000. Exactly. So logarithms, again, are another way of writing exponents. So if you have 2 to the power of 4, let's say, you can write that now, 2 to the power of 4 is actually 16, you can write that now as log base 2. Again, bases don't change. 16, right? What power do I need to raise 2 to get 16? I need to raise it to a power of 4. That's essentially all logarithms are. That's basically the general idea behind all logarithms. They're just another way of writing exponents. So hopefully this video was interesting and it taught you a little bit about logarithms. When I first learned about logarithms, it was very exciting because I'm used to seeing powers like 2 to the power of 3, what is that, 3? 4 squared, 5 to the power of 4. I'm used to seeing it like that. I've never seen it written another way. Now, well, you have another way of writing exponents. So in future videos, I'll probably talk about logarithm properties, logarithm equations, how you solve them. But if you have the general idea of logarithms now, that 2 to the power of 3 equals 8 can be written as log base 2, 8 equals 3. If you have that general idea down, you should be good now. And it's a really good idea to have in mind because all logarithms work with this property, which is, it's another way of writing exponents. So hopefully that video helped. I'll do more exponential videos. I'll probably talk about graphs and things like that soon, and other content for grade 7 and 8 as well. So hopefully these videos are helping, these videos are interesting, and yeah, keep watching for more math.